Hello. So, good afternoon, all. Myself, Pramod Sarangi. I am the regional manager for the technical in EDS technology for GEOVIA support and services. Welcome all for this webinar. So, we are going to give the overview of GEOVIA Surpac and Minesched in underground mine design and scheduling. So this webinar will give you a total planning and scheduling how to prepare with Surpac and Minesched software. Regarding EDS technology, we are celebrating this year 25th years of our inception. We are started with 1994 and focused with PLM solutions, sales implementation, support services, including mining. We are the platinum partner to Dassault System and the largest PLM and engineering solution provider in India. We are having more than 1500 customers and near about 120 mining customers in India. We are having 11 offices across India, and we are having strategic alliances with world leaders who are providing software and services. We are having dedicated sales and support marketing and customer satisfaction audit teams. We are also having e-learning portal for various engineering courses as well as on the product and services. And we are having the complete system integration skill within our team. So in order to continue this webinar, Mr. Arunava Banerjee is the technical specialist. So he will take you through the application of the Surpac and Minesched in underground application. So I am just handing over to Arunava Banerjee. So in between, if any questions or any sort of your query is there, so there is a question panel, so you can write it there. So at the end of the session, we will clarify all the questions and we'll discuss that what is the solution in related to the queries. So Arunava, please start your webinar with the details.
Thank you, sir. Good afternoon, all. So let's start with my introductions. Myself, Arunava Banerjee. I'm the geologist with more than 10-year experience in mining field. I'm associated with EDS technologies for more than 5 years. So let's start with my presentation. So today's topic is stope solids, stope optimizations in underground mines, underground mine designs, ring design, development and production scheduling using the mine scheduling software, and graphical outputs and reporting. So these workflow are divided in 5 steps. One is the geology, resource modeling, strategic mine planning, mine designs and scheduling. The first two parts, geology and resource modeling, are used for open cast as well as can use for underground mines also, designs purposes. Similarly, the next part is the strategic mine planning, mine designs and scheduling only used for underground mining purpose. Underground mine workflow supported by GEOVIA Surpac and Minesched include geology supports several key processes including drill hole logging, solid modeling, and structural modeling. Resource modeling support all the key components required to support reserve submissions, including geostatistical modeling, resource estimations, simulations, as well as uncertainty analysis. Strategic mine planning is the latest additions of Surpac 2019. Is newly introduced in Surpac. In mine designs feature of Surpac cover of every considerations of underground mine designs, including most noticeably level designs, haulage designs, blast designs while in productions. The last step is the scheduling is divided in 3 parts. One is the mining rule setups, the fix the targets, and finally gets graphical output and reporting. So few benefits of Surpac underground features is the total solutions to end-to-end solutions. So as we Surpac for open pit and underground is part of a complete solutions, while Surpac it is a total solutions for modeling and design, providing everything you need to handle geology modeling and engineering design tasks. It is also part of a wide solutions that includes geological resource modeling, handling of a strategic mine planning and optimization. It is very easy to use, extreme compatibility, is a user-based software. Surpac enjoy large and loyal GMP user base. It is easy to find people who know the Surpac, and it is easy to train people who want to know it. The automation is the very important features. You can record and playback your workflow. Free viewer visualizations tools are available, loading all data, sectioning, block model, drill holes, animations, measure distance, area, volume of the DTMs, solid models, block models, and other parts. Is a different type of features there. Multi-languages support. Surpac is used around the world, being available in different language. Is the role-based software role-based and module-based. Customized workflow, tailor the user interface to your particular requirement. So only what I would need. In health resources, detailed reference manual and step-by-step tutorials are present in the software. In some situations, you will have existing solids that conform to the mining constraint, such as minimum mining width, angle of the stope. If you do not already have solids that conform to the particular practical mining constraints, you can use the stope designs, stope slicer features of Surpac to create these solids. In stope design, you digitize graph polygons and planes and join them together to form a solid with a shorter distance between the polygons. You create more detailed stope solids. The distance that you need to choose depend on how much detail you require. You also need to make sure that the stope shapes you create are spatially mineable and practically mineable. You design the stopes so that your mining equipment can mine the stopes. So 8 steps are in these solid preparations. The first step is the display the block model in Surpac window. Second is the start a new stope design project and put a new name. Third steps is the choose a plane and digitize a mineable shapes around the ore body. 4 steps. Step number 4 is the choose another planes and digitize a mineable shape around the ore body. Step number 5 is the evaluate the stope polygons that you have digitized. Step number 6 is the continue moving from the plane to plane, digitize polygon, evaluating stope polygons until you reach the end of the ore body to mine out the complete ore body purposes. Step number 7 is the create the digitized object to use in the stope slicer and end the stope. The last step is the end the stope design project. So using these 8 steps, we can prepare the solid based on our requirement, stope requirement, the width of the stope, length of the stope, height of the stope, and create a solids. If you have this type of solids before at the time of the block model, so you no need to generate this type of solids. So in type of then the time of digitizations, the evaluate stope polygons is generated. You will create one polygon on each of these planes and object outwards from the polygon to create the stope. This function is called evaluate stope polygon function, which report on grade of the material, metal content within the stopes, mass volume. You can generate within a report within each rock type. Next is the stope optimizations in underground mine. Surpac 2019 adds stope optimization capabilities to its existing underground designs and engineering solutions. This enhances both the stope designs and stope slicing capabilities by providing underground engineering and engineers the ability to conduct strategic planning for their operations. GEOVIA Stope Optimizer allows the automatic generations of stope designs for a variety of underground mining methods. Underground mining engineers are able to optimize their strategic plans based on the selections of either value, cutoff grade, or calculated value. Optimizations occurs a number of practical control around the safety such as stope and pillar width, hanging and footwall attributes, execution zones, dike faults you can consider, etc. The optimizations process allows the mining dilutions and control over many other optimizations and stope designs constraint to ensure as little manual work in required at later planning stage. GEOVIA Stope Optimizer is fully integrated with the Surpac, allowing underground mining engineers and planners to take advantage of all other existing geology and planning data along with the full automations through the advanced Surpac scripting and capabilities. In stope optimizations, stope shapes for a range of underground methods. Inventories from block model specially represent locations of mineralizations, maximum recovered resource above cutoff grade or block value. These block value are calculated by the selling price, mining cost, processing cost, royalty, mining recovery, and processing recovery. In stope optimizations, the inputs are minimum and maximum mining width, anticipated wall dilutions, minimum maximum wall angle, minimum maximum stope width, pillar width, maximum slide ratio. This side ratio taken from top, bottom, front, back, footwall, hangwall. Geological structural constraint, geometrical constraint, stope material constraint. These are the inputs in stope optimization. So in stope optimizations, these are three benefits, major benefits. One is the higher profitability, safety, and design efficiency. In higher profitability, the minimum about the waste is mined to extract the maximum cutoff grade to meet profitability requirement. From safety point of view, size and shape of the stopes, pillar width, mining width, side wall angle, stope width, all are maintained by the stope shape optimizer. And the last benefit is the design efficiency. Automated stope optimizations will allow you to analyze the scenario more accurately and faster time to complete the design. So this is a small demonstrations about the stope optimizations. So we can open, this is a solid model of the ore. The blue color is the dike of the cross cuts or disturbance of the deposits, and I can use a one control surface to prepare the stope generations purposes. Then open the stope optimizations operations tools and tabs you can use. Choose the block model here, and in output tab, stope solids, output reports name, and other output types you can put here. So this is the extension origin of the ore body. You can put here the slice to understand the ore body, and control solids. You can put different type of control parameters you can put here. Stope width, minimum pillar width, maximum site ratio. You can, these type of parameters you can put as an output. We can divide your ore body is the full safe stopes or subset stopes. These options also available, and you can browse the existing disturbance part, suppose faults, dikes, etc. And in cutoff points of view, a cutoff. You can use the value of the block model, cutoff grade, or calculate it directly from here also. And you can control your stopes and validate all those things, save your parameters, and run the model and run the total operations. After that, you just cancel this one and reset graphics, and you can open the stopes. These are the stopes. There are full shape stopes and sub shape stopes. Both are, you can see here, and the die are totally excluded from your stopes, and you can identify individually. And in property window, you can see the metal content, volume of the stopes, the tonnage of the stopes, stripping ratio of the stopes. You can identify separately. The next is stope slicer. In stope slicer, enable underground mine designs to produce tactical mining shapes quickly by divided by solids into smaller solids that represents the stopes units to be mined. Slicing object to plane group definitions to provide volumetric and naming attribute. Options to exclude solids and design pillar. These pillars are two types, is the prone pillars and vertical pillars. Optionally selecting a block model to extract grade and classifications attributes. In reporting purpose, reporting the volumetric to CSV formats or text format of the slicing shapes. Saving to DTM presence attributes and header of object. The stope slicer methods are normally, we can use several type of methods to create the stopes. One is the elevation wise methods. We can split our solids in 2 or 3 parts. Is called 2 or 3 parts means crown pillars and stopes. Stope length wise we can divide the pillars and crown pillars. Plane wise we can divide 3-4 parts, and crown pillars, vertical pillars, and stopes. And we can control the stopes tonnage wise, volume wise. This is the very important options here. So this is the workflow of the stope slicer. The slicing, first choose the DTM file, and there are several type of methods, levels and stopes, levels only, stopes only. We can browse the different type of planes in different orientations, horizontal wise, vertical wise, and selection the exclusion part means dikes, or others part means declines, and development part. Naming purposes, suffix and prefix we can use for identification purposes for stopes, pillar, and crown pillars. And in block model, we can browse the block model. At that reporting time, we can calculate the tonnage and grade of the stopes. It's a very important and extra features here. So in results part, we can put the result name in different type of formats we can choose here. Stope slicer here divided in 2 parts. There is a crown pillars and stopes. Similarly, is a vertical wise we can split in 2 parts, vertical pillar and stopes. These are both of 2 cases, label wise and vertical wise stopes, and combinations of both, and we can identify each stope wise their volume, mass, metal content, and ratio of the ore waste ratio. Everything we can calculate. The next is, other than stope slicer, in underground designs we can digitize level design, cross cut, accesses, underground drive and decline, rises, and shaft designs is possible through the Surpac software. Next is the ring design. Ring design is the terms given to drill a fan of holes from a underground drive for the purposes of blasting ore. Surpac can help you create and report any feasible underground ring designs. Fully featured underground blast designs accommodates any mining methods, easy workflow that allow users to design at the excavations and safety specifications, easy reporting and plotting, powerful automations to save time and avoid human error. So in ring designs, there are several type of options are there. In set of options, rig properties, rig positions, drilling parameters, charging parameters, explorations parameters, delay properties, and there are different type of parameters and properties we can set based on our requirement. In viewing options and editing options also there, so we can edit anything based on your requirement. Viewing purposes, you can view hole id, hole length, hole diameter, delay, sequence of the holes, and explosive types. In charging options, single charging, multi-base charging, manual sequencing at the time of blasting, auto sequencing at the time of blastings, you can set based on your requirement. The rig properties is the very important chapter for ring designs. So we can set the pivot properties, carsol properties. So length of the carsol, left wise, right width, left width, right width, bit distance, feet pivot distance, pivot offsets we can assign based on our requirement and based on the mining activities. And we can rotate our machines in 360 degree, 180 degree, or based on the deep direction wise. So any angle you can, in any angle we can put the holes for blasting purposes. So in ring designs, for plotting and reporting purposes, you can drilling reports, blasting reports, explosive mass report, mass report, easy plotting is available in Surpac software. Next is the development and production scheduling in GEOVIA Minesched. In Minesched workflow are divided into 5 major steps. First one is the define geology. To define the geological model is where we define a block model. For each block model, we get to define the material contents as well as the grades. Second step is the setup development. In this, we define the central line designs of underground scenario as well as the parameters that are associated with the central lines. Things like crosscut, sectional profile, density, names, and other parameters. In open pit production scheduling, this step is not required. Third step is the setup scheduling. Setup scheduling is where we define the vast majority of mining rules. For example, we get a define the source and materials such as pits or stopes. We also get to define the destinations of the materials such as stockpiles, auto passes, crushers, and plants. Also, we get to define the flow of materials, resources, calendar, and other activities and targets. 4 is the create scheduling. The step 4 is the create scheduling. In create scheduling, we can define the timeline. The timeline contains all of the period, and we get to define how many periods are in your scheduling as well as the size of those periods. Other feature of the tab is the customized and configurable dashboard, and we can add chart, graph, report to the dashboard, and we can use this dashboard for data analysis, the analysis of the results of the scheduling, and there are few other features such as animation campus. The last step is the publish result. We can export our result to various famous such as we can write period number back to back block models, or we can export the mining blocks and mining polygons to geometric format like Surpac or AutoCAD. We can create end of the period surface in the case of open pit, but most importantly, we can create custom reports in MS Excel format, Gantt chart in MS Project, or write the block period numbers back to the original block model. Few key features in development and production scheduling. The first is the development and production. Mindset is used to schedule development as well as the stope production. Second is the rule based. As the user, you define the mining rules and mindset will always follow them. Next is the targets. When choosing the optimum mining sequence, mindset will provide you with the options that comes closest to meet your defined targets. Long to short term, mindset can be used equally for long to medium to short term scheduling purposes. Material movement is the next part. You can define where material goes and when. The haulage calculation the number of trucks required to execute the schedule and how many trucks hours. Haulage calculations use really 3D haulage routes defined by the user. Then is the graphical output. Choose the output, mining polygons and mining blocks. In reporting, fully customizable reports in MS Excel format. So few benefits of development and production scheduling in mindset. Mining planning engineers can achieve scheduling objectives quickly and easy by create and comparing different scenarios. Reduce mining cost by the preparing practical scheduling with rules, constraint and capacity scenarios. Lower pricing cost by meeting feed grade requirement with target scheduling algorithm. Validate scheduling by visualizations them in 3D animations and sharing them via a interactive viewer. Accept any popular GMP live formats for creating a mining scheduling. For underground mines, support scheduling for development, advance as well as the stope production. Manage stock files from different locations. We can accumulate the stock files, high grade, medium grade, low grade and waste. So this type of management is possible through the mine scheduling softwares. Calculate haulage requirement and all minerals and all mining methods that support in mine scheduling software. Publish scheduling results to a variety of different outputs such as Excel, MS Project, any database or mining productions intelligence solutions like GEOVIA Insight. The other benefit is quickly and easily update the starting positions of the scheduling based on survey results and productions report. Enable part of the short internal control process as users can easily update scheduling based on the current progress. Users can select individual mining locations and track the progress of all productions activities. All mining positions will be ignored when the scheduling is run. The animations and all exported graphical results will reflect the tracking updates available for surface and underground scenarios. So as a input value, we can use different type of models here in mine scheduling software. Surpac block models, micromine, datamine, James, Maptech, Whittle model we can use. Minex grid model also we can import in mine scheduling softwares. CSV files or Excel sheet files we can import to run the scheduling of your selective locations, and string file we can use here as the input. Few type of constraint we can use to maintain or control our scheduling. The surface, different type of surface we can import. Stope solids or pillars, crown pillars, vertical pillars we can import here to control drives and polygons and center line. So this is one demonstrations for my scheduling setup development tab. First we browse the string file from Surpac softwares, import these string files and put the name of each and every segment wise. You can put the name and we can select individually or we can drag over here and select the portions based on our operations, and we can put a name and give a star. So we can choose the particular locations for development purposes, for selection purposes, or activity purposes. So after that, in connections tab also there, in connections tab we can target or we can assign the material flow in a MySeedling software. So one segment to another segment, one row to another, one level to another level, we can assign the material flow targets and directions. So next is the parameters. We can identify the profile, the different type of profile we can use for the shaft, in the decline, in cross cuts. There are different type of profiles we can make here, and we can browse in here to create the actual scenario or for volume calculation purposes and tracking all those things. And in case of the evaluate part also there, in we can convert it in solids. So you can see it's automated preparation of the solid using the profile lines. And last one, the evaluate part. So individual solid we can select here, and you can identify the length of the solids, volume of the solid, mass after excavations, the after develop in the development part, the mass of the solids, and metal content. If it is in a totally waste, the metal content is 0. If it is in the ore, so we can get some metal content, so we can find out the ore at the time of the development. So this is the setup scheduling part of in a scenario 1. So we can different type of parameters here. One is the blasting, barricades, backfilling, activity, different type of activities. Here 3 processes here. One is the stope preparations, mining, and backfilling. We can browse each and every stopes which we have prepared in Surpac software. Browse the stopes, each and every stopes here, and we can stope preparations with different type of parameters we can assign here for mining purposes, quantity, value, units of the stopes. Mining purposes we can use the constant here. For backfilling purposes we can put the backfilling materials, the volumes of the empty volumes of the same we can put here. We can display the name of the stopes also to identification purposes. The next is the stope. After stope we can connect to stopes and developments and material movement, and total material is stacked in a stockpile. So different type of stockpiles we can prepare. One is the waste dump which used for the backfilling purposes. One is the stockpiles for material stockpiles in underground or in the outside of the above the surfaces. So different here, so different type of levels are there, level A, level B, level C. So different type of materials, the western part at the development time we can material flow in a west part, and ore are flow to the underground ore stockpiles and surface stockpiles, and last go in plant based on our targets and requirement purposes and for processing purposes. This is the material flow, so we can control the material flow from one locations to another locations based on our requirement. In underground tab, productions, process tracking options also there. So material movement we can control here. From first we target level A, level B, and level C, this type of material movement, and after blasting, so which are empty first, and then backfilling purposes we can target which part. So this type of tracking options also there, and we can identify each and every stockpiles quantity, quality we can identify here. In underground, these are the directions you can see the arrow. It means this is the empty or mining directions and backfilling directions of the stopes. In the development tab, we can assign different type of development machineries. One machinery is jumbo machinery is used for development purposes. That's why you can see here the length of the machines per day, capacity of the length, and there are 3 type of jumbo machineries we can use for the mining purposes, stope excavation purposes, and per day capacity we can assign here. In underground and stockpiles, so we can put the different type of materials put in the stockpiles, and in different type of parameters we can use here. Different type of parameters means in you can easily visible the block factor, block volume, maximum active locations, swell factor we can use here as a parameter. And in precedence parameter, here also different vertical lag distance, horizontal lag distance, block in sequence or not, we can control from here also. In calendar, different type of calendars we can use here for mining purposes, for plant purposes, for processing plant, for crew purposes, for development purposes. There are two type of calendars we can prepare. One is the working calendar for development purposes, one is the holiday calendar for day-to-day work purposes. In target step, we can put the quality targets. Similarly, we can set the material ratio target for the same to maintain the stepping ratio. This is the mindset output dashboard. So here we can choose the time span. So we can run the seedling for short-term basis as well as long-term basis also. And we can see the development movement, the bar chart. We can name of the stopes, start date, end date, durations. You can visualize here, and the starting time, ending time, the label wise you can visualize in the Gantt chart. So this is the scenario or animations. The first development is start, then mine out the stopes, and backfilling options also there, and yellow parts also backfilling by the waste material. And here also period name, stope preparations, and stope materials which you mined out, or stope preparations length per day wise or period wise, and backfilling materials. In scenario 1, the you can as the output, this is the animations we can see. So first we start from the development. So this is the development part. So per day wise we can assign the length, the development, and stack in a waste dump or stockpiles. And after a certain time you can assign the machineries development purposes as well as the mining purposes also. After a certain time we can start to backfilling of the same. The yellow part totally backfilling parts after mine out the material. And different type of reports you can generate, period wise, length of the waste, undefined, remove from the all developments, length of the ore, remove from the all development, and chemical wise or radical wise we can calculate the reports, and we can import different formats. So this is the output, different type of output we can generate. One is the graphical results, haulage results, animations we can save separately, standard reports we can prepare, customized reports based on our requirement. We can set the columns name and row name also. Gantt chart we can separate easily in separate, and update our existing block model, Surpac block model we can update as a new attribute. So this is a scenario, second scenario of the same in the Surpac underground. This is the Surpac underground designs. We can digitize the vertical shape, shaft, cross cut, declines, and solid models also, and we can convert it into block model to calculate the grades before start the seedling or optimizations of stope optimizations. So in Minesched software, the in scenario 2, the setup scheduling is there. In setup scheduling, we can import the string file which you digitized in Surpac software, and we can convert to a DTM with profile line, convert in solids, and import the solids or solids, direction of mining you can assign, and after the start the scheduling based on your requirement, quality wise and target wise. In after run the schedule, First, we develop the shaft, then axis, and then cross cut, and start to mine out the materials. Period wise, we can see from short-term seedling to long-term seedling. So this is the output, Gantt chart output and graphical output. The number of periods, start date, end date, activity types, mining locations, resources, which type of resources you can use for mine out the material. So you can generate this type of reports also, different type of graph chart or histograms you can generate, or tonnage and grade tonnage wise graph you can generate. Development and handling purposes, the waste development handling and refill or backfilling purposes, with how much material you can use, these type of graphs you can generate from here. And in activity Gantt chart, the name of the machineries or name of the locations, start date of the mining, end date of the mining, durations of the particular locations, and suppose 1 day or 2 days or 3 days, you can durations you can easily visible through the Gantt chart. The Gantt chart is very important role in underground mining or open cast mining purposes. So identify the durations of the mining in that particular locations, as well as to meet your target and achievement in quality wise and quantity wise. Gantt chart in MS project, so period wise development you can see. So similarly you can see the Gantt chart, the starting time and ending time for development purposes, and similarly you can see the output bar chart or histograms or bar charts. So these type of outputs you can generate any times, and you can easily modify any parameters in mine seeding softwares and run the same scenario within few minutes or maybe 10 to 15 minutes. You can get new results or new outputs. So currently Surpac 2020 versions are available, and Minesched also 2020 64-bit versions is available in our right now in our solutions and in our company. And system requirement, there are two type of system requirement. One is the minimum specifications for run the software Surpac Minesched, and recommended specifications is our recommended is 16 GB RAM is required for to handle the huge data sets, and these are requirement to handle easily. So thank you all. So any questions regarding that, so we can ask all.
Yeah, thank you, Arnavo. So I think this session definitely give a overview of all the participants on the application of underground mines in production as well as in development. So I would like to request everyone. So if any question is there, definitely we'll come back to you. So we'll discuss on this one. So request all of you to just write the question answer so we can revert back.
Pramod,
so there is a one question is already there. So hello.
Hello, sir.
So there is a question already, it is there. So whether we can able to incorporate the physico-mechanical properties of the rocks. Yes, definitely we can able to incorporate this information while preparation of the geological modeling work. So while preparation of the geological section and block modeling, so that if you can put the input, what is the rock type and how the rocks geotechnical strength and all these things, so that information will be definitely visible in your block model, and during your production and development process you can able to find out that where is the rock of your I mean say high strength or low strength, or depending on the geotechnical parameter whether it will be available there or not. Then there is another question, do we study the effectiveness of the supporting system like rock bolt and cable bolts? Exactly, it is coming under the safety parameter of your simulation part. Mostly that the software does not give the answer directly. But however, if you are having the geotechnical information or the study of that particular deposit, then you can able to incorporate those information as I rightly said in my earlier question or answer. So you can able to incorporate that one in the particular location, so that during the mining or the development or the blasting, you can able to find out that which part is your weaker zone or any joint or any other structural information it is there available in that particular deposit. So if you can able to put it in the geological modeling, so that can be visible in that areas, and based on the strength of the rock or the particular mass, so you can able to use the rock bolt. But software will not tell that whether you will put the rock bolt or cable bolt, so that option is not available in software. But yes, you can able to put the information of that particular properties in that particular block, where the information you are incorporated or get the information from the field data or from the borehole data. So any other question? So there is a question whether Minesched can work on any type of mining model. Yes, Minesched is applicable. Minesched is applicable for any rock type or the mineral. So you can utilize it for your application. There is no problem at all. If the geological model is ready, then you can able to find out that particular application for your development and scheduling purposes. Then coming back to how many times we can run the Minesched for a better result?
Sir, yes, in times you can run the scheduling to get the good results, and you can change the parameters and you can run anytime, and based on your satisfactory level, when it reach, you can stop to run the schedule.
Okay. So based on your target and all these things, you can change the parameter, and you can see that how your result is coming near to the requirement or not. Based on that, you can run the schedule, and you can see that how the result is coming, so that there is no harm that to run the Minesched for a multiple time to get the better result, because it will take very less time to process the application or the options what you are given.
Yes.
Then coming back to another question, it is Minesched a totally different software or module from Surpac?
Yes, sir. It's a total different software. Yes, it's a totally different software. Surpac is totally different software. The Minesched is the add-on of the Surpac, the next process for next process purposes. So Minesched is totally different software for opencast and account setting purposes.
Okay. So then there is another question, that after preparation of slice plans, can we know the load-wise, level-wise thickness of the ore body?
Yes. After a slice plan, we can digitize that part. Level-wise, we can identify obviously the thickness of the ore body, and stope width also we can calculate from the slice plan to create the stopes before scheduling. So it's easy to or convenient to prepare the stopes. Yes, sir.
With grade also you can able to find in that particular application, so that you can have the idea that in this particular slopes what is the grade it is also coming, apart from the thickness and the load-wise details.
Correct.
Then coming back to, can we use Stope Optimizer for open cast mines?
Yes, sir. You can use the Stope Optimizer for opencast also, because using this Stope Optimizer we can calculate the blocks which is above the cutoff grade or reach our expectation value, the economic value, based on the sale price, processing price, selling cost, loyalty. So these type of which blocks are economically profitable, we can calculate easily from the Stope optimizations tools and tabs using that options, and after that we can use it is for opencast and underground based on our requirements. So obviously it is also usable for the opencast purposes.
Okay, Arun. Yeah. There is another question. What are the prerequisites in terms of data required for modeling purposes?
And first is the block model, then constant
it
different type
will
of
be related to as well as for the development purpose. Both the things you can reply.
yes. Okay.
Yeah.
So for block model, we can import in mine sibling softwares. Then for development purposes, central line of the shaft, declines, cross cuts, and then after that, grade, estimated grade of the block models, the lithology, quality, quantity, targets, calendars, the holiday calendars or working calendars, this type of inputs, and your processing plant capacity, your machinery's capacity, haulage plan by haulage polygons and number of dumpers, your material flow, and your stockpile informations, and label wise your mine out, stripping ratio, targets. These type of informations you can put one by one and get a good result. Yes, sir.
Okay, Arunava, yeah. So there is another question is that whether backfill barricade design is available or not.
Yes, sir.
Backfilling barricade design.
Both options are available in mine sibling software.
Yeah. So based on your backfill plan, you can design the barricade and all these things so that it will be just put your backfill material in that particular area so that there is no issue. So you can design it and you can also validate after the particular application also, so there will be no issue.
Yes.
So there is no other questions right the moment. So I think we'll wait for maybe another half a minute so that if anybody is writing any question, we can revert back. Or else I will request everyone to have a query if anything. So if you can write to us directly, so that also we can able to give the reply. And if any further detail presentation or any understanding you require, then we will be happy to give a presentation individually to address your queries. Meanwhile, one question came: mine ventilation related any input can be incorporated. So ventilation here we don't have any simulation module right the moment to see that how the ventilation and the fan positioning and all these things means to simulate. That option is not available, but however you can able to see that where is the outlet and where is the inlet of that particular your air movement and all these things that you can monitor, but it will not say that where you put your fan and all these things or where to do the openings and all these things. So that option is not available in the software.
Correct.
Then another question is that can we know the strength of the stope panel after retreating of the panels? Means it is related to the geotechnical parameter. So software will not do unless until you go for a geotechnical studies. So that is not possible to know by the software that what is the strength of that particular stope panel or after the retreating of that particular panel, because it is a separate aspect of the study. So which is have different application and different parameter. But however, you can able to put all these information in that particular rock in the geotechnical parameter as an input, so that you can have an idea that yes, these are the rock strength and all these things in that particular area. Maybe after stope panel and all these things you can monitor it, but software cannot tell you that what is the strength and all these things in that particular location. Then another question is that can we have dump optimization too with Minesched?
Yes, sir. Dump optimization also possible, and additive materials you can optimize here also.
So all the design and optimization is also possible in mine scheduling, so that how much material it is coming from your mines as a waste and all these things, that information you can able to optimize, and how much during your dump design part also you can tell that how much material can be accommodated based on your soil factor and all these things. So based on that you can plan that whether all the material inside your mines or how much waste it is coming, whether that can be accumulated in that particular dump or not, by taking the consideration of your IBM guideline that this is the maximum angle and all these things. So that optimization and the road design and the distance from your particular location, how much distance it will cover, and all these things. That optimization, how many number of truck or machinery is required to fill that particular dump. Everything is possible in Minesched software.
And additive materials also you can handle or scheduling in this software.
Yes, yeah. So thank you all, sir, for attending this particular webinar and having interactive session on this particular. Then another question is coming: any optimization on the fleet management or transportation links from stockpile to the destination?
Yes, sir. Haulage planning options also there to calculate the trucks and material movement with the availability of trucks and speed of the truck, and other ring pool options also there. Another methodology to identify or calculate the delay or speed of the truck based on the gradient. So these type of options also there. So it's the back calculations purposes, how many truck you require to movement purposes to achieve your material from the mines or stockpiles to your plant, or material movement from your mines to your plant. These type of operations you can do through this software.
Can we do the concurrent mining scheduling? Can we do the concurrent mining scheduling? Means simultaneously do the mining as well as scheduling of the particular thing. Yes, definitely we can do, depending on the availability of your stope and positioning of your ore body and all these things. You can do both the things.
Yes.
Design as well as scheduling, both the things you can do simultaneously based on the means available ore body and the geotechnical parameter. If it supports your mining methodology and all these things, then both the things can be possible simultaneously in this particular aspect.
Yes.
Yes, open pit and underground both also the software can able to handle. So there is no issue at all, because open pit will have the different application and the underground is having the different application. Both the applications can be able to handle simultaneously with the particular software. There will be no problem at all. In the same deposit, if above your open pit is going on and below your underground is also going on, so there will be no issue at all to have the particular means process to monitor in that particular deposit. There is no problem at all. So any other question? So I'm just waiting, or else we'll stop this webinar, and definitely we'll wait few more questions from your end if you are having anything. So you can directly write to us. So we'll be also in touch with you for further clarification. And I would like to thank you everyone for your time and attention to this particular webinar. And if any further technical requirement is there from your end, please speak with us. Then definitely we'll come back to you. Thank you all. Thank you, Arnava, for your presentation and all. So be safe and work with safety due to this corona and all these things. So thank you, everyone.
Thank you.